Hey guys, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, guys, we are still going through the grade 12 mathematics June 2022 paper 1, right? That was written by the Gauteng province learners. This video tutorial is a great way for you guys to do your revision of your term 1 and your term 2 work. In this video tutorial, guys, we are going to be tackling question 2. And in question 2, we are going to be dealing with a geometric sequence, a geometric series, and a quadratic sequence, right? So if your knowledge on your geometric series, geometric sequence, quadratic sequence is a bit shaky, please make sure that you watch this video where I give you guys an in-depth tutorial on how to deal with an arithmetic sequence, a quadratic sequence, and a geometric sequence, right? And also make sure that you watch this video tutorial where I also give you guys a nice summary on how to deal with the different sequences or everything that you need to know when you're dealing with these 3 sequences, as well as everything that you need to know when you're dealing with series, right? So please make sure that you watch this video tutorial, guys. It'll really help you better understand this video tutorial as well, and it'll also help you better approach this question in this video tutorial. Like I mentioned, guys, we are doing revision of our term 1 and term 2 work, right? So please make sure that you are subscribed to the channel, and also please make sure that you click on that notification bell so that you get notified every single time that I upload a new video tutorial, guys. The final exams are fast approaching, right? So we need to make sure that you are studying, we need to make sure that you are practicing, and we also need to make sure that we do not forget the work that we have done in our term 1 and in our term 2, right? So guys, please make sure that you're watching these tutorials, you've got your pens, you've got your exam pads, and you've got your calculators. You're sitting down and you're at least trying to do mathematics for 1 hour each day to make sure that you pass your final exams. All right, so without any further ado, guys, let's get started with today's video tutorial. Okay, question 2, given the geometric sequence 9/2, 9, 18, right? And this sequence ends at 2304, right? We need to determine in question 2.1.1 the value of R. Okay, so the first question is pretty simple, guys, because we are already told that we are actually dealing with a geometric sequence, right? We need to determine the value of our R, which is our common ratio, right? So how do we get our common ratio? We know when we're dealing with a geometric sequence, T2 over T1 is equal to T3 over T2, which is equal to Tn minus 1 over Tn, right? So we're simply going to use this to find what our common ratio is, right? So this is how you get your common ratio for a geometric sequence, right? Okay, so what is our T2? Our term 2 is 9, so the second term in the sequence is 9. What is our term 1? It's 9/2, right? So 9 divided by 9/2 is equal to 2, right? And then you can just quickly check that your T3, which is your term 3, divided by your term 2 should also still give you 2, right? So what is our term 3? It's 18, right? What is our term 2? It's 9, right? And 18 divided by 9 is still equal to 2, right? Therefore, right, our R for this geometric sequence is equal to 2. Next question. How many terms are there in the sequence, right? So guys, before we can even just get the number of terms that we have in the sequence, right, we just need to first get the formula for the nth term of the sequence, right? We already know that when we're dealing with a geometric sequence, right, to get the formula for the nth term, we use the general formula Tn, which is equal to A times R to the power of n minus 1, okay? We know that the A is actually what? The first term, right? We know that the R is the common ratio, right? So we can just substitute our A, we can substitute our R, right? And we'll have, right, the formula for the nth term of this geometric sequence. And once we've got the formula for the nth term of our geometric sequence, right, we'll just substitute this value, right? And we know that that is Tn, right? To find out what our n is, right? To find that position of this number is on our sequence, right? So let's just quickly substitute all these values, right? So what is our a? We know that our a is our first term. So this is our first term for our geometric sequence, right? And our first term is 9/2 multiplied by, right? What is our r? We found out, we just got our r, and our r is actually equal to 2. So we're going to substitute that into there to the power of n-1, right? So this is basically the formula for the nth term of our geometric sequence. Okay, and once we found the formula of our nth term of our geometric sequence, right, then it becomes easy, right? We already know that we've got the sequence 9/2, 9, 18, and the sequence ends at 2304, right? So this is the last value of our sequence, right? Or the last term of our sequence, right? We found that our formula for the nth term is equal to 9/2 times it by 2 to the power of n-1. And now we need to find out, right? We need to find out then at what position is this term, right, in our sequence, right? At what position is this term in our geometric sequence, right? So what do? We know that now this is our Tn, okay? This is our Tn. So we're going to substitute it into our Tn position, which is 2304, which is equal to, okay, 9/2 times it by 2 to the power of n-1. And then, guys, we simply now simplify this expression and solve for n. Okay, please note, if you do not know how to work with your exponential, or even if you've just forgotten how you solve exponents, or if you don't even know how to apply your log laws, you're going to really struggle with this question, right? So please make sure that you watch this video where I explain exponential laws, right? And also just follow with me just to see how you solve, but you need to be well in tune when it comes to your log laws as well as your exponential laws, right? So we're just gonna solve for your n here by first getting rid of that part there. So you can get rid of that part by either multiplying by 2/9, okay? So it's going to be 2/9 multiplied by 2304, which is equal to 2 to the power of n-1, okay? So why did I multiply by 2/9, guys? You just want the 9/2 to cancel. So for it to cancel on the right-hand side, you need to multiply by 2/9. When you multiply by 2/9 on the right-hand side, right? If you multiply by 2/9 on the right-hand side, you need to multiply by 2/9 on the left-hand side. So that's basically what I did there, right? I multiplied by 2/9, okay? And if you do something on the right-hand side, you need to also do it on the left-hand side. And now that cancels, right? Okay, and then you'll have 2/9 multiplied by 2304, which is equal to 2 to the power of n-1. Okay, then we can just simplify this further. Okay, 2/9 multiplied by 2304, right? You'll get that your answer is 512, right? If you just punch that into your calculator, is equal to 2 to the power of n-1. Okay, we still need to simplify this further. All right, okay. Okay, so how to solve this using logarithms, right? We're going to drop that n-1, right? So when you drop it, it's going to be n-1, right? Okay, and then it's going to be log of, right? This 512 is big on that side, so it's still going to be big on that side. So it's 512, right? And then since we're moving that 2 to the other side, it becomes smaller, right? So it's going to be log, okay? So the answer is log 512 base 2, right? Log 512 base 2, right? And then from here, guys, it becomes really simple, right? Because you can just solve for your n, right? And when you solve for your n, it's going to be log 512 base 2 plus 1 is equal to n, right? And then if you put that into your calculator, okay, you'll find that your value of your n is equal to 10, okay? If you're not comfortable with using logarithms to solve this, right, what we can do is, okay, you can use exponential laws. So it's going to be 500. So we can just obviously use exponential laws. So from here, if you're not comfortable with using logarithms, we can still use our knowledge when it comes to exponential laws to solve this, right? So it's going to be 512, which is equal to 2 to the power of n minus 1. Okay, so what does this mean? It means 512 is equal to 2 to the power of n multiplied by 2 to the power of negative 1, right? Because we know that when we are multiplying exponents that have the same base, you simply add your exponents, right? So because of that, we know that we can expand, okay, the 2 to the power of n minus 1 in that form. Okay, we're fine. And then from here, we can see that, okay, we can actually divide by that 2 to the power of negative 1. Okay, so if you divide by 2 to the power of negative 1, okay, you divide by 2 to the power of negative 1, 2 to the power of negative 1, 2 to the power of negative 1, right? You'll have 2 to the power of n, which is equal to 512 over 2 to the power of negative 1 is equal to 1024, right? And then here we basically need to change our base to be in the form of 2 to the power of something, right? So here it's basically you using the method of trial and error, taking 2 to the power of something, 2 to the power of something, until you find that, okay, 2 to the power of something is going to give us 1024, right? So when you check, you'll see that when you say 2 to the power of 10, you'll actually get 1024 and you 2 to the power of n, right? And then here, guys, I'm sure you can see this becomes easy peasy lemon squeezy, right? We are basically done, right? If you've got the same base, you can simply just drop your exponents. So your 10 is equal to your n, okay? So we can basically use these two methods to solve that, okay? If you're not comfortable with logarithms, you can still use your exponential laws to solve your question 2.1.2, okay? So let's move on. Question 2.2. Question 2.2. Given that the sum of this infinite geometric series is equal to 12, determine the value of m. Okay. So we know that we are dealing with an infinite geometric series, guys. If you kind of lost as to why I'm saying this is a geometric series, please make sure you watch this video where I give an in-depth explanation about the different types of series that you guys will be tested on, right? So this is a geometric series, and the sum of this infinite geometric series is equal to 12, and we need to determine the value of m. Okay, this question is out of 2 marks. All right, so let's see. Okay, so we're given that the sum of this infinite geometric series, right? Okay, given by 6 times m, all raised to the power of k minus 1 is equal to 12. We need to determine the value of our m. Okay, so first thing we know, guys, is that to get the sum of a infinite geometric series, we get the sum by using the formula, okay, a over 1 minus r. Okay, this formula, guys, is given to you in the formula sheet, right? You just need to understand when you use it, right? Okay. Okay, so to get a sum of a convergent infinite geometric series, we use the formula a over 1 minus r. Okay, so another thing that we need to remember, when you're given, okay, a series in sigma notation, guys, you need to write out the first 4 or 3 terms. Okay, so that's exactly what we're going to do. We're going to write out the first 4. I'm actually going to make it the first 3 terms. We're going to write out the first 3 terms, right? And we're told that this sequence starts at, or this series starts at k, which is equal to 1. So to get this first term, we need to substitute 1 in space of k, right? So we're going to say 6 to the power of m. When we see k, we're going to say 1 minus 1 because it starts at 1, okay? To get our second term is 6m. When we see k, it's going to be 2 minus 1. And then to get our third term for this series, it's 6m to the power of 3 minus 1. Okay, we're going to simply simplify that further. Okay, so it's 6, okay, m to the power of 0, which is going to be anything to the power of 0, guys. Anything to the power of 0 is equal to 1. So the answer here is 6. Then we continue. 6m to the power of 2 minus 1. So it's going to be 6m. 2 minus 1 is 1. So it's going to be 6m. And then the last term, to get the term 3, it's going to be 6 m. 3 minus 1 is m to the power of 2, which is 6m squared, right? Obviously, guys, you need to continue all the way to infinity, but we're not going to do that, right? Because by just getting the first 3 terms, that will help us to get our answer. Okay, it's not practical to go on and on and on. All right, so then from here, guys, another thing that we know when we're dealing with a geometric series or a geometric sequence, guys, is given by the formula Tn, which is equal to a times r to the power of n minus 1, right? Where to get your first term, T1, you substitute, where you've got n, you're going to substitute 1, right? So it's going to be a r to the power of 1 minus 1, which is a. Anything to the power of 0 is 1. Okay, so r is to the power of 0, which is equal to a, right? To get out T2, what do? You substitute 2 in the space of n, so it's a times r to the power of 2 minus 1, so it's a to the power of r. To get out T3 is equal to a times r. Where you've got n, you're going to put a 3 minus 1, which is equal to a to the power of a times r to the power of 2, and you go all the way up until Tn, right? So basically, that is what we're supposed to use to help us answer this question, right? So we've already found that for this series, okay, our T1 is equal to 6, our T2 is equal to 6m, our T3 is equal to 6m squared, right? Okay, and then we found that, okay, in general, for your geometric series, the geometric series is given as a, that's your first term, a times r is your second term, okay, a times r to the power of 3 is your third term, right? So we can basically now use this to help us find the value of your a. You equate the T1 with the other T1, the T2 with the other T2, and that will help you get your answer, right? So when you take your T1, right, so this is your T1 here, and you equate it with this T1, you'll find that your 6 is equal to a. So your a is equal to 6. We found the value of our a. We're fine, right? And then if you equate the T2 with the other T2, what do you get, right? Equate the T2 with the other T2, it's going to be 6m is equal to AR, right? And then here, what can we do, guys? Okay, what do we see? We have already found what the value of our A is, and your A is equal to 6. So when we see A, we are just going to substitute that 6 multiplied by R. And if you divide by the 6 and you divide by the 6, what do you see? You will see that your M is equal to R. Okay, so we found the value of your A, we found the value of our R, and then we can simply go to the equation. Okay, we can use the equation sum of infinity is equal to A over 1 minus R and substitute our values, right? Here, guys, we were given that the sum of our infinite geometric series is equal to 12. So S infinity is equal to 12. Okay, so that is 12, which is equal to, what is our A, right? Our A is equal to 6. And 1 minus, what is our R? Your R is equal to M, right? And you simply solve this equation for M, okay? So you can cross multiply, okay? If you cross multiply, you'll say 12 multiplied by 1 minus M, which is equal to 6, right? Then it's going to be 12 times 1 is 12 minus 12 times minus M is minus 12M, which is equal to 6. Okay, and then you collect your like terms. So 12 minus 6 is equal to 12m, right? And if you divide by 12 and you divide by 12, your m is equal to 6. 12 minus 6 is 6 over 12, which is 1 over 2. Okay, then you found the value of your m. Right, Question 2.3, guys. Okay, we are told that the third term of a geometric series is 18, and the fifth term, okay, so the third term, T3 of a geometric series is 18, right? And T5, the fifth term, is 162. We need to determine the sum, right? We need to find out what the sum is, right, of the first 7 terms, right, where your R is less than 7. Okay, this question is out of 5 marks. Okay, so how do we approach this question? Okay, first thing that you guys need to remember is that when we're calculating the sum of a geometric series, right, where your R is less than 0, your sum is calculated using the formula Sn, which is equal to A1 minus R to the power of n all over 1 minus R. Okay, so this is the formula that we use when your R is less than 0. Okay. The formula is slightly different, right, when your R is greater than 0. So please make sure that you watch this video, guys, because I give an in-depth explanation of how you basically calculate the sum when your R is greater than 0 or when your R is less than 0. Okay, going back to the question, right, we told that your T3 is equal to 18. Okay, and we told that your T5 is equal to 162. Okay, we need to find the sum of the first 7 terms, right? And we are looking for Sn. Okay, so what do we need for us to basically be able to substitute into this formula? Guys, we need the value of our R, and we also need the value of our A. Okay, so the first thing we're going to calculate, guys, is the value of our R, our common ratio for this geometric series. Okay, remember, guys, I told you that a geometric series can be defined as A, right, plus A times R plus A times R squared plus A times R to the power of 3 plus going all the way, right, to A plus times R to the power of n minus 1. It can be defined in the sense, okay, where your A is your T1, A times R is T2, A times R squared is T3, and going on and on and on and on like that, all right? So here we have T3 and we have T5, right? So we need to find a way that we can get our R using this T3 and T5 that is given to us. So what must you do? Okay, we can find what your T3 is, right? And we know that T3, guys, can also be written as A times R squared. Okay, and your T5 can be written as A times R, where you've got N, you substitute 5 minus 1, which is equal to A times R. 5 minus 1 is 4, right? So your T3 can be defined as A times R squared, and your T5 can be defined as A times R to the power of 4, right? So now what can we do with this information? Okay, let's find what R is. If you take your T5 and you divide it by your T3, what happens? Okay, if you take this T5 and you divide it with this T3, what happens? T5 is A times R to the power of 4. If you divide with the T3, it's going to be A times R to the power of 2, right? What happens? The A and the A cancel, right? And you've got R to the power of 4 minus 2, okay? So if you're dividing bases, numbers that have the same base, remember, guys, you need to subtract your exponents, okay? This is exponential laws, right? And therefore, your final answer is R is T5 over T3 is equal to R squared, okay? And then from here, guys, because we found that your T5 over your T3 is equal to your R squared, right? Then you can just simply substitute the initial value that is given for our T5, which is 162 over T3 is 18, and that is equal to your R squared. Okay, we're going to simplify this further. we found that your r squared is equal to 162 over 18. Okay, 162 over 18, guys. If you punch it into your calculator, you'll find that you get that it's 9. So r squared is equal to 9. And then if you just square root both sides, okay, to isolate that r, okay, you'll find that your r is plus or minus 3. Okay, we found the value of r. But guys, remember, we are told that the value of your r is less than 0, right? That means that from this value of r that you've just calculated, we need to take the r that is less than 0. So your r is equal to -3. So we found our r, okay? The last thing that we need to get to be able to now get the sum of obviously this geometric series is we need to get the value of our a, right? So how can we get the value of our a? Okay, how do you get the value of our a? Remember, guys, to get the value of your a, you can just use the formula Tn is equal to a times r to the power of n minus 1. Okay, we're already given either T3 or T5, so you can either substitute T3 or T5, right? So if you substitute T3, remember, guys, they told us that T3 is equal to 18, and they told us that T5 is equal to 162, right? So you can substitute either those values, either T3 or T5. I'm going to substitute T3, right? So we know that T3, the value of our T3 is 18, which is equal to A times, what is our R? We found that our R is -3, right? What is our N? This is the third term, T3 minus 1, right? And then we simplify this further. 18 is equal to A times -3 to the power of 2. Okay, -3 to the power of 2 or -3 all squared is the same as saying 9. Okay, and 18. And if you solve this for A, okay, you'll find that your A is equal to 2. Okay, guys, so we found the value of your R, we found the value of your A, and from here, it becomes easy peasy. We simply substitute it into this formula, right? So we get that the sum is equal to A times 1 minus R to the power of N all over 1 minus R, okay? We know that we're getting the sum of the first 7 terms, right? Therefore, your N is equal to 7, okay? Your A is equal to 2, and your R is equal to -3. Okay, so your A is equal to 2, 1 minus. Your R is -3. Your N is 7 all over 1 minus your R is -3. Simply punch that into your calculator and you'll find that the sum of the first 7 terms, right, of this geometric series is equal to 1094. Right, guys, let's go on to the last question. Question 2.4. The general term of a quadratic, right, number pattern is Tn, which is equal to an squared plus bn plus c. Okay, and its first term is 8. Okay, so we know that the term 1 of this quadratic number pattern, okay, this is question 2.4. Okay, we're dealing with a quadratic. Okay, we're dealing with a quadratic sequence, right? We are told that the general term for this quadratic sequence is given as Tn, which is equal to an squared plus bn plus c, right? And we are told that the first term of this quadratic sequence is 8. So T1 is equal to 8, okay? So we know that T1 is equal to 8, okay? What else are we given here? The general term for the first difference of the pattern is TK, which is equal to 4K minus 2. Okay, so guys, we know that when we're dealing with a quadratic pattern, we get basically the first difference and you also get the second common difference. Just a quick recap. When you're dealing with a quadratic sequence, right, we've got A, we've got B, C, D. So B minus A, C minus B, D minus C, okay? And then like that, right? These values here are considered your first differences, okay? Your first difference, and the values that you get there is considered as your second common difference, okay? When you're dealing with a quadratic sequence, right? So they tell us that for this quadratic sequence, right, the first term is 8 and the general term of the first difference, right? So to get the terms of, your first difference, you need to use the formula TK, which is equal to 4K minus 2, right? So to get these terms, you use TK, which is equal to 4K minus 2. Okay, so that's basically what the information is giving to us. Okay. Question 2.1 says, 2.4.1 says, we need to determine the next two terms of the quadratic number pattern, Tn. Okay, so with this quadratic sequence, we are told that the first term is equal to 8. Okay, and then we are told that to get the terms of your first difference, you use the formula 4K minus 2. Okay, so to get the first term, right, or to get the terms of your first difference, right, you use the formula 4K minus 2. Okay, so that means that to get the first term, right, we need to say 4 times 1 minus 2 is equal to, okay, so 4 times 1 minus 2 is equal to 2. Okay, so that is the first term here. Okay, right, and our first difference is 2. Okay, so to get now the second term in our initial quadratic sequence, we say 8 plus 2, which is 10. Okay, then we continue to get the second term of our first difference. It's 4 times 2 minus 2, which is equal to 4 times 2 is 8 minus 2 is 6. Okay, so that means here at the bottom, we've got a 6, right? And then 10 plus the 6 is equal to 16, right? And then, guys, we have basically calculated the first two terms of this quadratic number pattern, right? And the first two terms for this quadratic number pattern, right, is given by 10 and 16. Okay, so question 2.4.1, the answer is 10 and 16. Those are the next, actually not the first, the next two terms for this quadratic number pattern. Okay, question 2.4.2, hence or otherwise, show that the general term of the quadratic number pattern is given by Tn, which is equal to 2n squared minus 4n plus 10, right? So guys, okay, this one is nice and simple. Okay, so 2.4.1, right, we need to basically prove that the formula for this quadratic sequence is given by Tn, which is equal to 2n squared minus 4n plus 10. Okay, so what do we know, guys? When we basically dealing with a quadratic sequence, right, we know that we use the formula Tn, which is equal to an squared plus bn plus c, right? And to get your a, right, you just say 2a is equal to your second difference, right? We know that 3a plus b is equal to t2 minus t1. And then we know that a plus b plus c is equal to t1, right? So we're going to basically substitute all these values and prove that, in fact, the formula for the nth term of this quadratic pattern is given by 2n squared minus 4n plus 10. Okay, so let's start. 2n 2a is equal to the second difference. So what is our second difference? Okay, so if you go to our previous slide, how do you get your second difference, right? This is our first difference where you take your term 2 minus your term 1, right? This gives us your first difference. And to get our second difference, we simply take second common difference, right? We just take this 6 minus 2. 6 minus 2 is equal to 4. Okay, right? Okay, so our second difference is equal. So our second difference is equal to 4. So 2a is equal to 4. So divide by 2, divided by 2. A is equal to 2. Okay, let's continue. Okay, second equation, we say 3a plus b is equal to t2 minus your t1. Okay, so what is our term 2? This is term 1. This is term 2. Term 2 is 10 minus t1, which is 8. So 10 minus 8 is equal to 2. Okay, so t2 minus t1 is 10 minus 8, which is 2, right? And then we already found that your a is equal to 2 plus b, which is equal to 2, right? And if you simplify that further, you find that your b is equal to -4. And then last one, a plus b plus c is equal to your term 1. What is our term 1? Our term 1 is 8. Okay, so what is our a? We found that your a is 2 plus what is our b? Your b is -4 plus c, which is equal to your term 1. We said your term 1 is equal to 8. Okay, and then if you simplify that further, okay, 2 minus 4 is -2. So it's 8 plus 2. So C is equal to 10. Therefore, we found the values of your A, your B, and your C. You can simply just substitute it into this equation, Tn, which is equal to An squared plus Bn plus C. What is your A? Is equal to 2, right? N squared. What is your B? It's -4n. What is your C? It's 10. Okay, so we've proven that this quadratic sequence is given in the form of 2n squared minus 4n plus 10. Okay, and last one. Which term of the quadratic pattern will be equal to 3050? Okay, so we're trying to find out, okay, which term will be equal to 3050. We are looking for, right? This is our Tn. We are given what our Tn is, right? That is your Tn. We want what the n is. Okay, we already know that the formula for the nth term of this quadratic pattern is given as 2n squared minus 4n, right, plus 10. They want to find out which term will be equal to, right? So which term, okay, will be equal to 3050, right? That is your Tn. So 3050, right, is equal to 2n squared minus 4n plus 10. Guys, here, guys, we are going to equate this equation to 0. So it's like saying 2n squared minus 4n plus 10, which is equal minus 3050, which is equal to 0, right? And then you simplify that further, you'll get that you get 2n squared minus 4n plus, not plus, minus 3040 is equal to 0. And then, guys, here you can just simply use the quadratic formula, right? You can either, we're going to use a quadratic formula to calculate the n. So instead of writing x there, guys, you do realize that we're going to write n because we're looking for n and not x, right? Which is equal to, because that is your a, that is your b, and that is your c, right? This equation is in the form of a x squared plus bx plus c, right? It's in the standard form of your quadratic equation, right? Something n squared minus something n minus c or plus something, right? So something n squared plus something x plus the constant. So it's in that form, right? So we can use the quadratic formula to simplify this further. All right. From here, guys, if you've basically punched those values, punched this equation into your quadratic formula, you'll find that your n is equal to 40 or your n is equal to negative 38, right? But what do we know when it comes to a sequence? A position in a sequence cannot be, you can't have a negative position in a sequence, right? So that basically tells us that this is not applicable, right? N cannot be equal to negative 38. Therefore, your n is equal to 40. Okay, so which term of the quadratic pattern will be equal to 3050? That term will be term 40. Term 40 will be equal to 3050. And that is your final answer. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.